Okay, uh, so we can write like this: 1/2. So for m, this beta, okay, we can write like this. So because instead of c square minus 4mk, we can write it as 4mk minus c square. Okay, and then multiplied by -1. So it will be 1/2m like this. So under root -1 is I for the complex numbers and identity for the complex numbers, and then we call this other identity something like this as omega star. Okay, so we say that omega star is equal to 1/2m under root 4mk minus c square. So therefore beta will be equal to omega star I. Okay, omega star I. So the roots of this equation will be then lambda 1 will be minus alpha plus beta, minus alpha plus omega star I, omega star I, and L lambda 2 will be minus alpha minus omega star I. So in other words, the solution will be y of t will be equal to e power minus alpha t, a cosine omega star t plus b sine omega star t. And this can be represented also just like we did for the undamped case, was that we can represent it like this: c times, instead of these representing these two constants a and b, we can represent it with the single constant c, e power minus alpha t times cosine of omega star t minus delta. Okay, where c is equal to same as before, a square plus b square, and delta is equal to tangent inverse b over a, or tangent delta is equal to b over a. So in this way it can be represented. So this is a brief theory for the damped springs. But remember that we have considered two cases, undamped and the damped. Okay. However, we did not consider any external force in that. So that is the another case that we will consider later on. So let's see now this with the help of the example. So as a numerical example, we see that how does the motion in example 1 change if we change the damping constant c from 1 to another of the following three values, with y0 is equal to 0.16 and y prime 0 is equal to 0 as before. So three situations have been given, and in those situations you can see that the damping force is different as given by the damping constant. So here it's more, here it is middle, and here it is less. So actually we have to find the solution of these two in these three conditions. So remember that now the we need some data from the previous case. So the data from the previous case was that the value of k was The value of K was 90, okay, Newton per meter, and the mass was 10 kilogram, okay, if I remember correctly. And then now the first case, now C is equal to given as 100 kilogram per second. So the equation is, if I remember, the equation is something like this, okay, the general equation: C over m y prime plus K over m y is equal to 0, okay. So we can see that the equation is y double prime C over m, it's 10, plus C is 10, 10 over 10 is 10, y prime plus K over m is 9, y is equal to 0. So the characteristic equation will be m square plus 10m plus 9 is equal to 0. So this equation factorizes into m plus 9 and m plus 1 is equal to 0. Yes, yep. So it has two distinct real roots. m1 is equal to minus 9, m2 is equal to minus 1, okay. So its solution will be c1 e power minus 9t plus c2 e power minus t. So for the values of C1 and C2, we can apply the initial conditions. So Y0 was 0.16. So 0.16 is equal to C1, that will be 1, plus C2, that will be also 1. So C1 plus C2 is 0.16. C1 plus C2 is equal to 0.16. And y prime of t is now minus 9 C1 e power minus 9t minus C2 e power minus t. So y prime of 0 was 0, so 0 is equal to minus 9 C1 minus C2 is equal, that is 0. So we have these two equations, so we can solve this by adding. So if I take this equation, minus 9c1 here and minus c2 here is equal to 0, and I add these two equations, I get minus 8c1 is equal to 0.16, and c1 is equal to then minus 0.02, right? If I divide 0.16 by 8, I get 0.02, minus 0.02, okay. And then this will mean that C2 is equal to 16 minus C1, so 16 minus 0.02, it will, because it was minus 0.02, it will be plus, so it will be 16.02. So the final solution for the initial value problem is C1 was minus 0.02 e power minus 9t and plus 16.02 e power minus t. Yeah, it's not 16.2, it's I made the mistake, it is 0.16. So 0.16 plus 0.2, so it should be 0.18. .18 plus 0.18. Okay, so this is the solution for the first part with C is equal to 100 kilogram per second. For the second part, So C over M, so will change. So the second part, C is equal to 60, okay, kilogram per second. So the equation will change like this. Y double prime plus 60 over 10 is 6. So y double prime plus 6 y prime and plus 9 as before. So this is a complete square in terms of the characteristic equation. M square plus 6m plus 3 plus m 9 is equal to 0. So it is m plus 3 square is equal to 0. So there is a double root equal to minus 3. So its solution, general solution will be y of t will be equal to c1 plus c2 t e power minus 3 t. Apply the initial conditions 0.16 into c1 plus c2 times 0, and then this term will be 1 because t is equal to 0. So here, from here we can find that c1 is equal to 0.16, and then y prime of t is equal to c1 plus c1 plus c2 t into minus 3 e power minus 3t, and then 0 plus c2 into e power minus 3t. I have applied the product rule. Okay, so y prime of t was 0, so c1 plus 0 minus 3 into 1, okay, and then it will be c2 into 1. So here I get 0, it is I get minus 3c1 plus c2. So from here c2 is equal to 3c1, so it is 0.48. So in this case what I get is the solution y of t is equal to 0.16 plus 0.48 t into e power minus 3t. Okay, so yeah, one thing I want to mention is that you can also plot the curves using Mathematica to see how the solution is showing any trends. Okay. Okay, so now the third case was c is equal to 10. Let me confirm. C is equal to 10 kilogram per second. Okay, so the characteristic equation will be y double prime plus 1 y prime plus 9 is equal to 0. This will be the characteristic equation. Sorry, the differential equation. Because m was 10, c was 10, so c over m will be 1, so it will be 9. So for this characteristic equation, we can find for this differential equation, we can represent it as a characteristic equation m square plus m plus 9 is equal to 0. So in this case, m will be from the quadratic formula minus 1 plus minus 1 square minus 4 times 9 is 36 over 2. So it is this one. So minus 0.5 plus minus